Very good morning to one and all present here. So my name is Ravi, working as Assistant Professor in the Department of ECE. Today I am going to share with you some of my thoughts with the title of the overview of cellular communication technologies. Actually, this concept arises from the 1940s. The basic aim of this concept is nothing but to provide the connectivity, to provide the service geographically. Geographically, it's supposed to be connected. That is a major objective for this, so that this concept arises. So first of all, we will see that what is cellular. Actually, as I told you that from 1940s, the first 1971, the Bell Laboratory proposes the concept of the cellular concept, and based on this particular concept, the geographic service areas are divided into number of cells. So here the main thing supposed to be maintained is nothing but the neighboring cells should not use the same frequency. Okay, so the number of cells are there, the neighboring cells should not use the same frequency, and the reason for this is nothing but to prevent the interferences. And the next one is the approximate coverage area. Actually, the cell size normally we used to say it is a circular. Okay, so the approximate coverage area for the circular, we have to come up with the idealized hexagon. Okay, that is the shape for the cell to analyze very easily. So here the next we are going to see that why we choose this hexagon. Okay, so we can able to choose that the number of shapes also. For example, triangle also we can able to take, square also. Then we can able to see that the coverage area, the maximum idealized is hexagon. Okay, so next the next is to increase the system capacity. There is a possibility of use the frequency reuse. Where this concept comes, actually as I told you that we can have a number of cells are there, but the adjacent cells should not use the same frequency. Then where the frequency use will come. Okay, so the group of cells we used to call it as a cluster. Okay, so for that group of cells with the different frequencies we used to have, okay, some other group we can come up with some group of cells are there, so we can able to use the same frequency which you use in the another group. That is called as a frequency reuse. So here in this diagram itself we can able to see that the coloring which defines that a different frequency. Okay, so here we can able to see that this is one cluster. Okay, so this one cluster, it is having 7 number of cells are there, each cell using different frequency. So you can able to see that different color represents different frequency. So this is one cluster, this is another cluster. Okay, so here is also some different colors are there. You can able to match that the frequency reuse concept will come. This cluster, this cell use this frequency, the same frequency can be used here in this cluster too. This is frequency reuse. Again you can able to see that the another cluster, the same frequency is using here. Okay, so in order to improve the system capacity, we can able to use the same frequency which you use in the clusters. Okay, so we can able to have a number of clusters are there in a system. Okay, while talking about a system, we can have a number of clusters are available. So this frequency reusage concept will comes into the picture that you want to increase the system capacity. So the next is we can have a theoretical propagation pattern. As I told you that it is a circular pattern only. Okay, and if we talk about cellular grid design, okay, so that is in order to attain the approximate coverage area, we are supposed to come up with the hexagon shape. Okay, so this is cellular grid design, but practically you can able to see that this is the actual cellular grid layout. Okay, so as I told you in the previous slide that the size of the cell is a circular. Okay, to attain the maximum coverage area within that cell. Okay, so the shape, the idealized hexagon shape we choose. Okay, so from here we can able to see that the maximum coverage we can able to attain from here. Okay, so here, so the propagation model represents, as I told you, it is circular area only. So if you want to approximate the cell coverage area, the size hexagon we chosen, and it will allow us to do the analysis very easily. Okay. So the next is the frequency assignment. Frequency assignment normally we used to represent it as capital F megahertz for a particular system, and while talking about the multiple access techniques, that translates from F to T number of traffic channels. Okay. If F translates T number of traffic channels, this multiple access techniques. Okay. Actually this multiple access techniques are used in a system to access a channel in the cell. That is a major role for this access techniques. So normally we have three different type of access techniques. One is frequency division multiple access techniques, time division multiple access techniques, port division multiple access techniques. So we have three different type of multiple access techniques. So this access techniques, we have to keep in our mind that to get access to the channel available in the cell. Next is, if we define K, it is a cluster of the cells. A group of cells we used to call it as a cluster. Okay. So the adjacent cells for a particular cell is a cluster of cells, we used to define it as a K. Okay. So with the different kind of frequency assignments which is available. So the question may arise, okay, while using this cellular communication, why can't you use a large radio tower and a large service area? Okay. So here the answer is very simple. So the number of simultaneous calls that will be limited. This is because of, as I told you, that traffic channel is defined as T. Okay. So based on the available traffic channels only, it can be encouraged. So the simultaneous users are limited. Okay. So that is the reason. The next thing is the mobile handset uses the power requirement is very high. Okay. So that is based on this reason only we used to go for the tower size, as well as the cell size will also be reduced. The next is, in the cellular concept, basic is nothing but we used to choose normally smaller cells and frequency use concept. And the advantage for the cellular concept is nothing but we can able to have a low power handsets, and by using a frequency reuse we can able to increase the system capacity. And the drawback also, we supposed to have the cost of cells. Okay. So we supposed, while talking about the cost of cells, if we take a cell, we need to have a base station. Okay. So for that arrangement we have to define it, and that base station as well as a mobile switching center. Okay. So for all this arrangement, okay, it will count into the cost of cells. It is one of the drawback. Okay. So after that, the handoffs we will see in the next forthcoming slides. The handoff between the cells must be supported, and it need to track the user to route incoming call and messages. Okay. So here, if we define, let T be the total number of duplex channels. Okay. As I told you, each cell it will come up with the number of channels are available. Okay. So if we define it as a duplex channel, okay, duplex means it needs that streaming is in two lines. Okay. Either it may be a transmitting, both receiving at the same time it will do. Okay. So two channels will be there, one is for incoming, one is for outgoing. Okay. So two processes will be there in that particular channel, that is called as a duplex channels. We are defining it as a T over here, and here we are defining K. It is a size of the cluster. Size of the cluster, it is a typically we used to define it as 4, 7, 12 and 21. Okay. So I will tell you the next slide also, it will come in the clear picture. Okay. So the typical size of the cluster, it is defined as 4, 7, 12 and 21. Okay. And the number of channels per cell can be calculated while taking this calculation T by K. Then we can able to calculate the total number of channels available in the cell. Okay. So if the clusters are replicated, okay, so in the previous slide we have seen that the number of clusters can also be replicated within a particular system. Okay. So the replication of clusters can also be defined how many times we have to take into consideration, that is m times. Okay. Then we can able to calculate the system capacity, also we can able to calculate with this how many number of times it is replicating, and this total number of duplex channels. By multiplying these two, we can able to get that the system capacity. Okay. So, and here the choice of this K, the clustered. Okay. So, this will determines the distance between the cells using the same frequencies. Okay. This is called as a co-channel cells. Okay. So, I will show you in the figure also. Okay. Okay. So, this is an example how it is coming up. Okay. So, here we define that the cluster size K is equal to 7, and if you say that the cluster size is 7, the frequency reuse factor for a particular cluster, it is supposed to be 1 by that cluster size. So, this is the meaning of this is nothing but, if we say it is a cluster, okay, only one frequency for each cell supposed to have. Okay. So, that is the meaning of this. Here we have 7 number of cells are available in the cluster. There is supposed to be only one frequency for each cell. Okay. And assume that T is equal to 490 total channels. This definition is for cluster. Okay. For a particular cluster, if we define that 490 total number of channels available in a particular cluster, then we can able to calculate the total number of cells, the total number of channels per cell n is equal to T by K by simply dividing this 490 by 7, will get 70. It is number of channels per cell can also be calculated. Here we define this is T is equal to 490 and K is equal to 7 and n is equal to 70. Okay. And if we take the clusters are replicated with 3 times, this is capital M, okay, then system capacity can also be calculated with this value 1470 total channels. This is available in a system. Okay. So, that is what we have to understand. Okay. So, this 490, it is for one cluster and this is for a total system, because we have taken that a cluster is replicated 3 times, simple multiplication of this 490 into 3. This is a very simple calculation. Okay. So, next, as I told you that the cluster size is typical, as I told you, then that is as I told you 4, 7, 12 and 21, how it comes. Okay. This is an example over here. This is a geometric rate of hexagons. Okay. So, the equation for this is nothing but the cluster size K is equal to I square plus Ij plus J square. Here this I and J are represented as non-negative integers. Okay. So, here this is an example, very simple example. If the cluster size is 4, okay, then we supposed to have the value of this non-negative integers I is equal to 2 and J is equal to 0. Okay. So, if we substitute these two values here, we can able to get 4. Okay. Accordingly, we can have a cluster like this 1, 2, 3, 4. This is one cluster with 4 number of cells are available in this particular cluster. Similarly, for example, this K is equal to 7, we supposed to have an alternate value, that is I is equal to 2 and J is equal to 1. While substituting here, we will get K is equal to 7. Here it is an example. Here how many number of clusters available in this particular system? 1, 2, 3, 4, 5, 6, 7. Okay. Simultaneously, K is equal to 12. This is a representation of one cluster over here by having value of I is equal to 2 as well as J is equal to 2. Simultaneously, as I told you, another typical value, that is 21. Okay. So, 21 can be obtained when we have the value of I is equal to 4 and J is equal to 1. We can able to have the total, right. So, next. So, the next concept is nothing but we have to identify the co-channel neighbors. What is co-channel? What is the procedure over there? With the help of this non-negative integers, we can able to do some small process to find the co-channel neighbors. Okay. So, what we supposed to do? We have to move the I cells. We have to move I cells from the boundary of the hexagon perpendicularly. Then after that, we have to take a 60-degree angle and we have to take counterclockwise and we have to move J cells. This is a very simple procedure. Once again I repeat, from the hexagon the boundary of the hexagon, we have to take a perpendicular, then we have to move I number of cells perpendicularly, then from there 60 degree we have to take counterclockwise, then move j cells. Once it reach a particular cell, that is a co-channel cell for the origin. Okay, that is also, we have a diagram also. Okay, so in order to increase the system capacity, the co-channel cells as far as possible we have to place, okay, in the defined cluster size. And here we have three important parameters are available. Okay, so there is a relationship between these three parameters. One is nothing but the distance between the co-channel cells, the distance between the co-channel cells, then the cluster size and the radius of the cell. This three parameters is having its own relationships, or this d by r is equal to square root of 3 into k. This d is nothing but the distance in between the co-channel cells, and this r is nothing but the radius of the cell, and k is nothing but the sizes of the cluster. So this is the basic relationship. Okay, so as I told you that how it moves like this, the movement, the I movement as well as the j movement of cells over here, the distance can be calculated from here to here. This is d. Okay, the distance in between the co-channels available over here. Okay, as we know that radius is nothing but this one. Okay, the cluster size also we can able to define. Okay, that is k. Okay, and from this example clearly we can able to see that if we define that I is equal to 3 and j is equal to 2, as per the procedure as I told you that from this hexagon, from the boundary of this hexagon, we are taking I is equal to 3, that is move 3 I cells here, then from here 60 degree, from here 60 degree counterclockwise we have to take, then move j cells 2, that is. Yes ma'am, to identify the co-channel ma'am, to identify yes ma'am. Actually this process will reduce the interferences reduction. We have to identify a co-channel, we can have a number of co-channel. Okay, so from here this process, if we define it as I is equal to 3 and j is equal to 2, the same process it will be there for this particular cell. From this particular system we can able to identify for the cell it is having number of clusters, that is co-channels 1, 2, 3, 4, 5, 6. Okay, so these are all co-channel for this particular cell. Okay, these are all co-channel cells for this cell. Okay, so like this we can able to have a number of co-channel cells, and also we can able to have okay, so the next concept is frequency assignment. Actually this concept will come into the picture of to increase the available channels without compromising the quality of service. So where the quality, what is the quality of service means the effective utilization of the spectrum, and to increase the capacity as well as minimize interference. Okay, so these are all the quality of service we have to maintain. Okay, so here we have two different type of frequency assignment. The first one is fixed channel allocation, second one is dynamic channel allocation. Okay, so the first one is the number of traffic channels are fixed. Okay, so here the case is if all the channels are busy, at the same situation, if new call come from a mobile, okay, so that will be blocked. Okay, if all the channels are occupied as well as busy at that particular situation, a new call to or from a particular mobile, at the scenario that call will be blocked or that will be rejected. Okay, so that process will be done by the base station which is available in the corresponding cell. Okay, so the next is the dynamic channel allocation. So here the process is little bit different. Here the first thing is the base station, first it has to give a request to for the particular channel to the mobile switching center when the needed. Okay. So when it is a necessity only, the base station will give a request to mobile switching center for a allocation of channel. Okay. And after the allocation, this mobile switching center, it will take into the account. And here this dynamic channel assignment, it will reduces the probability of blocking. Okay. So as I told you that the fixed channel assignment, as I told you, when all the channels are busy, okay, so the next call, if it is coming in or going out, that will be blocked or rejected, as I told you. Okay. So this, the probability of blocking can be reduced with the second concept, that is a dynamic channel assignment. Okay. So and simultaneously the mobile switching center complexity will also be increased while doing this kind of process, and it has to collect more number of data on these are all the three categories, that is a channel occupancy, it needs the data, and what all the traffic distribution and radio signal strength of all the channels. These are all the data have to be maintained by mobile switching center while carrying out the process. So the next is cell borrowing technique. Okay. So in fixed channel assignment is concerned, as I told you that the blocking as well as call rejection will be happen when all the channels are busy. Okay. So here the another option will also be there, that this FCA in which a cell is allowed to borrow a channel from its neighbor with the permission of MSC. Mobile switching FC, that is, while implementing this, it needs one channel. There is a possibility you can borrow the another channel from the adjacent cell. That okay. So that will be carried out under the supervision of mobile switching center only. So next the concept is handoff strategies. So this handoff is nothing but when the mobile is moving from one cell to another cell, okay, what the scenario will be happened. Okay. So the call should not get disturbed from one cell to another cell. Okay. So here within a particular cell, if the call is going from the mobile, it's not a problem. Okay. So when the mobile is moving from one cell to another cell, during that particular transition time, a problem will come. During that time, what will happen? This mobile switching center, the major function it will carry out over there at that particular point, that it will allocate a new channel in the next cell. Okay. It will collect that particular signal and it will allocate a new channel to the next cell. Okay. So that handovering that same signal from one cell to another cell by the mobile switching center is called as handoff. Okay. So this process without disturbing a call. Okay. Without disturbing a call, that call will be transferred from one cell to another cell. Okay. So in one cell, that call is utilizing one particular channel. So it is nearing that border of the particular cell, the mobile switching center, it will take that, it will allocate a new channel with the new cell handover without disturbing a call, so that there is no rejection, there is no blocking of calls over there. Okay. So the next is, so a new call to avoid a call cut off in the mid conversation. Okay. So that is the important point over here. Okay. So and the priority is concerned, each cell it is having its own priority. Okay. So if the call is coming, okay, so priority is second one. The first priority is nothing but handoff is the first priority. Okay. So if any handoff signal is there, the first priority will be given to handoff only. Second only, the another call will be taken, the second priority. Okay. So in practically we can able to see that each cell it is reserved for some channels to carry out the process of handoff. Okay. Each cell is having some set of channels reserved for to carry out the process of handoff. Okay. So next in this handoff, the minimum acceptable level, okay, so that is established for the receiver signal to maintain the call. Okay. So actually we have to calculate the threshold level also, handoff threshold level, okay. So that margin is supposed to be del is equal to handoff power minus minimum power, that is a margin, okay. So this is an example for improper handoff. So we are taking that the received signal level with respect to time, okay. So here in this particular region only the handoff process will be carried out here, okay. A is in another cell, B is in another cell. When this user moves towards this side, okay, when A to B the process will be happen, okay. So here the received signal level will be high at this particular point. When it is moves here with respect to time, the signal level will keep on decreasing. At this particular point, the situation over here is level at point B, all is terminated because the signal level is low, okay. So this kind of handoff is called as improper handoff. So that's what I defined, that the margin is supposed to be maintained, okay. So here is also the same. It is an example for proper handoff. Here is also the same example. So what we have done is we have to maintain the signal level, okay. So from here the maximum it is coming, okay. So the level of the handoff is made over here and it has transferred to BS2, that is this BS2, it has been transferred from here to here. Again the signal level is maintaining from this particular point. So this is the process of proper handoff. So in another session let me continue with this, okay. Thank you very much for your